Welcome back to the formulaic approach. Now, you see, I often have students tell me things like, I don't understand physics or I don't understand any of the science subjects. Now, when they come up to me initially to ask me that, firsthand, I tell them, go and read your book, because I believe that if the fundamental problem of knowing how to read and write is solved, then you shouldn't have any problem reading. Now, you shouldn't have any problem with your subject, rather. Now, except you are reading the wrong materials. If you are consuming the wrong materials, for example, maybe materials that are too advanced for a level, or materials that don't explain things the way you can relate with them, then maybe you should change. But if not that, I tell them, read your book with an open heart, and by so doing, you will probably be able to do well in your subject. But then some of them say, I am reading, but I am not understanding. And I tell them that I ask them if they have first developed interest in that subject. If you have not developed interest in your subject, there is no how you will read and understand fully. Okay, sometimes you might even still read and understand fully, but you will not know too much. You will not know more than you are reading. I don't know if you understand me. Because you see, knowing more comes from inquiry. Is that okay? Knowledge comes from inquiry. So if you don't inquire more, you cannot know more. And that inquiry stems from your interest. So if you are if you are uninterested in what you're reading, then you cannot make inquiries, okay? So now that problem is now solved. You have begun to love your subject, and you have begun to understand what you're reading. But then you ask me, why am I not understanding? Why am I not having the best of results? Now here is my response to that. Now you are not having the best of results because you are staying on what you have in your textbook alone. Let me repeat that. The reason why you are not having more than the average results now, even though you are reading and understanding what you're reading, is that you are not necessarily, you are staying on just what you are you see in your textbook. So you are not necessarily advancing in your reading. You are not advancing in your knowledge. Let me explain what I mean. Now, you see in your textbook, for example, I want to explain why some students don't understand physics. I was engaging some of my students recently, and I began to, nudge them to ask fundamental questions. You see, you need to know how to ask fundamental questions in order to be able to understand concepts. And in fact, that is when you can be able to test yourself, test your knowledge of what you are talking about. Okay, if you cannot answer fundamental questions, it definitely means that you don't understand that thing. You probably only know it. Is that clear? So recently, my students asked a question like, or I was the one who asked that, why is it that if you touched a live wire, a naked live wire, you touched it with a metal, that you will get shocked? But if you touch it with something like a dry stick, a dry plastic, that you would not get shocked. Why? Then someone stood up and said, because brooms are non-conductors or insulators, while metals are conductors. Then it seemed as though it was his moment and that he had gotten that answer very correctly. But of course, he was actually correct. But you see, then I asked him a fundamental question to know if he actually understood what I was talking about. I said, okay, why are metals conductors and why are non-metals non-conductors? Why are they insulators? Why are plastics insulators? Why are woods insulators? So why are those things insulators and then metals are now conductors? Then he said, because they can conduct electricity, so metals can conduct electricity. Okay, why can they conduct electricity? Why wood cannot conduct electricity? You see us reverting back to the first question now. Yes, because we are just moving between two ends. We are saying one is conductor, the other is insulator. Then one can conduct electricity, the other cannot conduct electricity. You are saying the same thing. All right, so why can those guys actually conduct electricity? The metals that we call conductors. Now you have to understand that. So when you begin to ask those kind of questions, then you see that your knowledge will begin to expand. Now let me give you the context of let me explain that context now. So for example, why do we call metals conductors? Why are they able to conduct electricity? That's essentially what we are saying. And these other guys are not able to conduct electricity. All right. Here is the simple answer. The simple answer is that metals have free electrons in them. And so because there are free electrons that are mobile, then once you connect them to an electric source, they are able to what? Use the electrical energy to move the electrons, isn't it? But these guys, the non-conductors or insulators or dielectrics, they do not have free electrons. Okay, so then what does that mean? Why are there free electrons on metals and there are no free electrons on non-conductors? I mean, both of them contain atoms. So why are some having free electrons, then why are the conductors having free electrons, and the atoms of the insulators don't make their electrons free? You see, you are beginning to ask fundamental questions, then your knowledge, your scope of knowledge will begin to open. Do you understand now? So for example, I would say that now electrons, we say metals or conductors have free electrons because there is the atoms the valence. Okay, in an atom, let's take an atom. Begin to look at an atom now in a metal. Begin to look at an atom as a, just begin to, you can't see an atom, but like think of an atom that you can see right now. You already know that an atom has a nucleus that has the proton and neutron, then surrounded by clouds of electrons that occupy energy levels, right? So those energy levels are far away from the nucleus. So think of it as, say, the nucleus does not have huge amount of attraction to the electrons. The nucleus is not holding on tight to the electrons, so because of that, the electrons are almost free to move, or actually free. They are actually free to move. But in insulators, the nucleus is holding on tight. The core is holding on tight to the electrons, so it's not allowing them to be mobile. Okay, and then you think, what does that even mean? Why are the atoms? So are you saying that, Master? Are you saying that the atoms of these guys of metals are not they are generous, they are not stingy, while the atoms of non-conductors are stingy, they are holding on to their electrons, and so because of that. Now, that is another fundamental question, now, and I'll explain that the atoms of, now, let's now take an atom again, like I said. So in an atom, if we view an atom, we have the nucleus, which is the core, then we have electrons in orbits, right, in energy levels around it. Now, if you take one atom, that is the case, but in a solid metal, for example, now the atoms are very, very close to each other, so for that reason they split, they mix together and split into what we call bands. Now, there are three such bands that you should know, two such bands that you should know. We have the valence band and the conduction band. Now, the valence band is the one that is occupied by all this is a valence band. Now, the valence band, we view valence band in terms of the outermost valence electron shell. Is that okay? The last electron shell is the valence band, okay? And it is formed by not one atom, it's formed by all the atoms that are together in a region, in a particular space, in that our conductor. So many atoms together, they will form a conduction band around them and a valence band, okay? So this valence band is the band that contains the last electrons, the outermost electron shell. That's the valence band. So the conduction band is the one in which free electrons are found. So the free electrons can move here. So it means that if an electron so this is the way it is arranged. So there is a valence band. Let's say this is the outermost electron shell of many atoms here. So inside this band here, this one you are seeing here, this second one I drew here, we'll call it the valence band. So electrons are found there. okay, held onto. Electrons are found here and they are held onto. So outside of it is the conduction band. So this is the conduction band. Once you can make your way out of here and escape this place, then the electrons are said to be free. Why these ones are said to be bonded, right? They are bound electron. Okay, so it means that the conduction band is higher in level than the valence band. Okay, so in the valence band, electrons do not move around. Electrons move around actually. Electrons do not electrons are not free. I don't know if you understand. Electrons have not escaped the atom that way. Does that make sense to you now? So electrons are not free, and that's the way metals are. So but the thing insulators rather, that's the way they are. But the thing that separates insulators and conductors is this. Now you see for conductors, this conduction band and the valence band, they overlap. So if this is the conduction band, the valence band will just be inside like this. They will overlap each other such that there is just little amount of energy or no amount of energy is even needed for electrons to escape here and begin to move and be called free electrons. Do you understand now? The electrons are free to move. So once you provide them with just a little bit of potential like this, they begin to move. You provide them with a little bit of energy, they begin to flow. So because of that, these guys can conduct electricity. Okay? And of course, there are many things to that. There is much more deeper than that is taking place. But I want to explain them in terms of those conduction band. Okay? So in this conduction band for these guys, for insulators, you will see that the conduction band is very, very far away from the valence band. This is the conduction band, this is the valence band. So because of that, no matter the amount of energy that you provide these guys, you need a huge amount of energy to provide them to actually move. Okay, now the band difference, let me just get into a little bit of something that is quite deeper. The energy level, the energy difference between them is greater than 5 electron volts, and you can think that one is very, very small, but of course in the realm of atoms it's a very big amount of energy. So 5 electron volts is what this guy needs, any electron here needs to escape. But here they don't even need they overlap. They overlap means they already fused into each other, so meaning that electrons here can just gain any amount of energy and then leave and begin to flow. Electrons are free. They don't need any surge, they don't need any amount of energy, extra energy to begin to move. Do you understand now? So that's the case for these guys and these guys, and of course insulators and conductors. And of course, based on conductivity, conductors. So based on conductivity, we now rank things as conductors, non-conductors, and semiconductors. With semiconductors, the energy band, this is called the band gap. So the band gap, the difference between the valence and conduction band in terms of energy is just around approximately 1 electron volts. Okay, this is for semiconductors. So what does that mean? It means that once you excite them just a little bit, then electrons can begin to move in one direction. Okay, now as I said excitement, you might now begin to think, what is the excitement again? Now the thing is this, that at absolute zero level, which is 0 Kelvin, that is absolute zero temperature, that where the internal energy of a system, the internal energy or thermal energy of a body is zero joules, that is the energy has zero internal energy. Okay, now at that level there is something called the Fermi level. The Fermi level is just the level below which you will see below which electrons will arrange themselves. Let me reiterate, you are going to understand what I'm talking about now. So at absolute zero temperature, electrons begin to arrange themselves in lower energy levels first, and then they begin to move. Think of the way they normally sit in a stadium. Okay, so in a stadium, the rows are arranged from bottom like that, and then the seats rows begin to increase higher and higher, right? So that way, think of electrons filling from the bottom that way too. So electrons of very low electrons tend to occupy the lowest energy they can possibly be in. Do you understand? And begin to go on like that and like that. So the highest level there where you find an electron is the Fermi level. Okay, so beyond the Fermi level at zero, at absolute zero, there is no electron, and below that is where you begin to see electrons in a particular atom. Do you understand now? Okay, so now, and there is actually a mathematical relationship for that to calculate, to see where the probability for, it's called the Fermi-Dirac distribution. I'm just trying to touch on this so that you understand that there's something deeper to this than just this can conduct, that cannot conduct. You see, when you begin to understand these intricacies, then science becomes fun. Well, maybe the mathematics might now piss you off, okay? Because, for example, the Fermi-Dirac distribution probability has the I think this is the probability, the energy probability, the probability that at an energy level we have electrons is given by 1 over I can't even remember right now. I think 1 plus exponential E minus E sub F over E minus E sub F kBT. Okay, so this temperature, this K sub B is Boltzmann constants, that is 1.38 times 10 to the power minus 23. 1.3 as K sub B, 1.38 times 10 to the power minus 23 joules per Kelvin. Then the E sub F is the energy level of reference, and E is the total internal energy, and exponential, of course, the constant. Okay, so when you see this kind of equation, for example, you begin to say, this thing does not really, maybe you now begin to get pushed away. But the point is, okay, let's say you are a medical student, you probably don't even need this, okay? Or maybe you are, but because you are doing physics, you think you don't need this. But because you are doing physics, you probably need to read to this level. So until you now see the mathematics, then you now say, okay, because I don't need this mathematics, which could actually help you to understand it better, though, but because you don't need this level, you already understand, have a deeper knowledge. Do you understand? And you see, the deeper the knowledge, the deeper your inquiry, the more the concept become simpler kind of to you, the deeper your inquiry. Because when you begin to ask questions deeper, it shows your level of comprehension. Okay, but because, for example, Empedocles was the first person to ask what is actually light? Why do we see? So, and when someone says something like, what is light? You think, light is light. But light is not just light. Okay? So, for example, as I was explaining to my students, that you begin to vibrate an electron at speed of what we call speed of light, 300 million meters per second, then you see radiation that we call light. That is what light is. Okay, then they don't understand that because they feel like, okay, we can't really see anything vibrating in this light right now. But because you now begin to reason at those levels, then you now begin to think, oh, electrons are vibrating, okay, so how does that cause light? Then we say the electrons that are moving have both electric and magnetic field, and then they feel, wow, okay. You see, the deeper you begin to reason, you begin to understand more and more. That's just what I'm trying to say here. Do you understand now? So conductors are not just conductors because they are conductors. It's because of this electron, the conduction band, valence band thing, you understand? So you talk of metals, electropositive, and metals are electropositive, which means that they're able to give up their electrons quickly, right? So that also explains it. Do you understand? So that's why they are conductors. They are not just named conductors. Do you understand now? All right. So, and the measure of conductivity is also given by, I think, NP mu. I can't remember this formula, but like, I'm just showing you that, you see, these things have mathematical representations, but you can, as you make your inquiries, those mathematical equations, they begin to make sense. You begin to know what they mean. Do you understand? So And as well, in other sciences, like I've said, in other sciences, you hear, why is an atom this and that? One of my students asked me one time that, why is diamond, that he is thinking that if the intramolecular forces in diamond are so strong, there are covalent bonds throughout, that, so what is the bond like at the end of a carbon, since it is continuous covalent bond throughout? You see, that's a deep question, because you begin to envisage how the structure will be, because if it is strong intramolecular strong covalent bonds, let me just use that, strong covalent bonds throughout, and then so it means that carbon should form a very large structure that is endless, right? So why do they now break into things? Even naturally they exist, as we see them naturally, they are, in some particles or in a big large chunk. Why do they exist in those chunks? Do you understand? Then you begin to understand, okay, impurities might come in during their natural process of natural formation, and so because of that, intermolecular forces cause them to be destructible at some points. You understand? So those points are destructible, and then they form those shapes and those structures. Do you understand now? Okay, so the portions where the 4 covalent bonds are formed on each of the carbon are the points where the carbon is indestructible. The diamond is indestructible, except by another diamond, of course. Do you understand? So the more you begin to ask these questions and begin to see things not just from the perspective of the textbook, begin to think, inquire what the textbook means by that, the more you begin to understand in science. I hope you have gained something from this video. Do well to subscribe to the channel and click the bell notification. If you want me to drop any video on any of these things I've explained, or any science subject or topic at all, put them in the comment section. I'm going to attend to them. God bless you.